My Stirling single, part 45, a modification to the suspension of the tender to make it match the height of the locomotive. Before commencing the modification to the suspension, I thought I would have a look through my box of 2BA bolts to see whether I had any stainless steel ones. I need these to fasten the frames to the tender tank. But as you can see by using a telescopic magnet, most of these bolts, apart from the brass ones, seem to be magnetic, which means they are not stainless steel. And before any experts write in, yes, I am aware that some stainless steels are magnetic, but all of the stainless steel that I use is non-magnetic, and here to prove that are 4 bolts, which are not very influenced by the magnet on the end of the telescopic rod, so these should be fine for the job. The only thing is, I wish they were a little bit longer. I may have to make 4 stainless steel bolts from some stainless steel hexagon bar that I have in stock. Back to the episode. This episode is about springs. As was the previous one, I fitted 6 springs to the tender, which are made from a heavier gauge wire than these ones. What I'm going to do is make some adapters to hold each end of the spring. That means I won't have to grind down the springs, which of course will shorten them, which in turn will drop the level of the tender frames on the axle boxes. Here I'm having a look at what size hole is through the centre of one of these springs. As you can see, I'm just using a twist drill, checking the diameter of the twist drill with the micrometer. The job begins. I have the sizes, I've fitted a piece of bar stock into the chuck on my Boxford lathe, and here I am machining it. First of all I face across the front, and then I have to turn down part of the diameter to fit inside the spring. I started off by using my usual carbide tip tool, but then I thought to myself, well, this is going to take a long time because halfway through the operation I will have to change the tool. So instead of using this tool, I changed it. This is a parting tool, and as you can see, I'm using it for its intended purpose of parting off the finished component. This parting tool doesn't stick out very much from the tool holder, so it seemed like a good idea to use this for the turning operation as well, and here I'm turning the second component. This parting tool is a little bit high in the tool holder. It stops it from grabbing on certain metals. Not good engineering practice, but then with my work there's nothing new there. Here I'm using the parting tool as a normal turning tool, and it's working very well. Once I've turned down the piece of brass to the correct diameter to fit in the spring, all I have to do is note where the hand wheel is and then duplicate this for every other part. The job is very simple and very routine, and it's mass production on a small scale. I have to make 12 of these. Once I'd turned the part, I cleaned up the edges using a file. For some reason, totally unknown to me, in these days of bloodshed and destruction, more viewers than normal are commenting that they don't like the idea of filing near revolving chucks. My answer to this is it's quite simple. All you have to do is avoid hitting the chuck with the file. And even if you do accidentally catch the chuck, normally it just knocks the file out of the way. One health and safety notice that's very important though, whenever you're filing in the lathe, make sure that your file has a substantial handle. And I would normally file the part using the front end of the file only, which is much further away from my hand. Back to the job, I'm parting off yet another component and then straight away commencing making the next one, finishing the sharp edges with the file, followed by parting it off. To avoid viewers going into a coma, including myself, I haven't shown the making of every one of these. I'm now going to show the next part of the operation. Drilling oil ways through the centre of these parts, just to allow the oil to flow from the top of the spring all the way down to lubricate the axle in the axle box. The job starts with a centre drill, and you notice that the centre drill removes a little bit that the parting tool left. And after the centre drill, I drill all the way through with this twist drill. I centre drilled all of the parts first, and then I drilled them with the twist drill, and I soon got into the rhythm, and before drilling I cleaned up the outer edge of the piece of brass using a long folded strip of wet to dry sandpaper, 400 grit to be exact, and once I'd finished this sequence, this is what I ended up with. 12 special fittings to go into each end of the axle box springs. And just in case you're not sure what I'm doing, have a look at this. The two adapters extend the spring length, which should apply more pressure to the axle boxes, making them sit lower in the horn slots. I took the completed components into the house, because I have an extension to the house now, which is an extension to the workshop. In this image there are three things wrong. The first one is obvious. I do need to touch in the paintwork on the horn blocks, because on this one you can still see some of the original red paint. To be honest, this job is a bit of a comedy of errors. Apart from the axle box, the first problem was every one of the brass parts that are made relative to the spring that I used as a guide, which was actually bigger than the springs in these axle boxes. I went back up to the workshop and reduced the end of them to the correct diameter to fit the springs that I'm using on the axle boxes. The third problem was using one of these at the end of each of the springs was far too much. In the end, I only had to use one at each end of the spring. And in this clip I'm pressing the first one into one of the leaf spring castings. And as you can clearly see here, once I fitted the dummy leaf spring back in place, the coil spring was in exactly the centre of the axle box. After dismantling the suspension, fitting one of my adapters to each of the dummy springs and putting them all back together, I ended up with some spare parts, and I will keep these in the box of locomotive springs because I'm sure at a future date I'll use these again. Once all of the wheel sets were fitted in place, this was the result. By using a long, substantial Allen key, as you can see, both the tender frames and the locomotive frames are at exactly the same height. But some viewers may be thinking, well, what happens when you put the top of the tender on and fill it with water? Well, obviously it's going to put more pressure on the springs, but because these springs are far firmer than previously, the axle boxes don't drop very much, and to prove that, this clip shows the tender frames with my very heavy Stuart Victoria, which has a 1/4 inch steel plate mounting base. As an estimate, this is about the same weight as a tender tank when it's full of water. Each set of tender wheels are still sprung, but the entire tender sits level with the engine, even with the weight on it. I'll leave the Stuart Victoria sat on the tender frames for a couple of days, just to make sure that the springs don't get weak and collapse. I'm taking it easy at the moment. It's been 3 days since my prostate biopsy, and the instructions say I am not supposed to do any heavy lifting for the first few days, but I don't think that the tender tank is that heavy, so I'll bring it down into the house and fit it to the frames. That's it for this episode, and wherever you may be, stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.